Good afternoon to all my AP students. We are on our second podcast here in Chapter 15, and we're going to take and do a little summary of buffered solutions from section 15.2, and we'll talk a little bit about 15.3 today. So remember that a buffered solution has to have large amounts, large concentrations of a weak acid and a weak base. And the reason that we need to have these large concentrations is because we need to have a lot of hydrogen ions present, or we need to have a lot of hydroxide ions present in order to absorb whatever is trying to change the pH. The better that we can absorb this, the likelihood of the pH changing is much less. So if it has a large capacity, as we proved yesterday, you will see that you won't have to worry about the pH changing much. And so we always have to talk about this in pairs, as we saw in the Henderson-Hasselbalch equation, that we're always comparing the concentration of the conjugate base to its acid, or the conjugate acid to its base. So we always have to remember that we're taking a look at a ratio. So you are always going to see, remember, you have to get used to looking at that this is an acid. If you don't know the formula, write down HA. Everyone knows that that is a generic formula for the acid. Conjugate base, and this is our generic formula for that. And then we have our base and our conjugate acid, and that's going to be our generic formula for that. So we have the hydrogen ion added to a buffered solution. The reaction goes to completion when a weak base is present. And that is always going to be true. So you can see here I have a conjugate base, and I have another symbol for a base. In both situations, they are going to be weak, and you can see what our product is going to be. And so you would be able to go through, do ice, or do the Henderson-Hasselbalch to see if it's a good buffer solution or not. Here's another assumption that you have to remember, that if we have OH, that hydroxide ion is added already to an equation, this reaction is always going to go to completion with a weak acid present. And the reason for this is you can see that this weak acid is going to dissociate, and it's going to continue to dissociate until all of the hydroxide ions have formed into water. So this reaction is going to go to completion. The hydroxide is going to be at 0. And the same thing will happen for the base. Then you can see here's our Henderson-Hasselbalch, and this is true of buffering materials. You have to remember that we talked about that you always have to have it in pairs if you're going to use the Henderson-Hasselbalch equation. So you have to have its acid, weak acid, with its conjugate base, and then you have its base with its conjugate acid. They must be in pairs. And again, you can take a look at these ratios to determine if you have a good buffering material or not. And remember, our source of the hydrogen ion is what we are always facing. That's what we're always taking a look at. You need to keep that in mind. What is my source of my hydrogen ion? Because that is what is going to be affecting my pH. So moving right along to section 15.3, again, this is just a real summary of buffering capacity. It's the amount of protons or hydroxide ions. Remember, when we say protons, we are thinking of hydroxide ion or hydrogen ions, or hydroxide ions if we have a base. The buffer can absorb without significant change in pH. And remember, significant change is, it can't change by an entire number, because that's going to be a factor of 10. If you recall that if I have a pH of 4 and then I have a pH of 3, this 3 is 10 times stronger. That's not a great buffer. It has to stay within that range of a 4 in order for it to have the buffering capacity. So when choosing buffering components of an application, the ideal ratio is going to be 1. And this should make sense to you then, that the pH is going to equal my pKa, or I could say that my pH is equal to my negative log of my hydrogen ion concentration, which is equal to my negative log of my Ka. So in either respect, whichever way you like looking at it, we want that ratio to be 1. Then that means that I'm going to have a great buffering capacity. Now, I want you to grab your book. Go ahead and pause this if you need to do that for a second. And I want you to turn to page 695. And page 695, you are taking a look at page 695, you're taking a look at the exercise 15.8, the example there. So you can see a chemist needs a solution buffered at a pH of 4.30 and can choose from the following acids and their sodium salts. So that is the pair there. You are talking about, if we were talking about HCl, you'd be talking about HCl, and it is sodium salt would be NaCl, meaning we know that sodium is going to be the spectator ion. So that's what the verbiage, or that's what the wording means there. So if we take a look, you can see that we have those four acids. Again, remember the ratio that you can see there, that you need to have your ratio of your acid over your conjugate acid, or conjugate base, sorry, your conjugate base there. We want this to be equal to 1. And you can see that they took the 4.30 and we took the anti-log. That's a word that I've been missing when we've been converting this back and forth. So they took the anti-log of it and they found the hydrogen ion concentration. They plugged it into our formula in the Henderson-Hasselbalch. Go ahead and turn the page and you can see the results that they have there. So all they did was plug in the numbers, take a look at that ratio, and the ratio, the one that's closest to 1, is the one that you want to use for your buffering capacity. So in this case, you can see that you want to use the benzoic acid. So again, it's not a real big deal that what we're doing here, but we just want you to get to understand that not everything can be a buffer. And you need to have something that's only going to change this by a fraction of amount. Okay, I think that's all I wanted to say for this section. You guys are going to be starting section 15.4. We're going to do that part in class. And the next podcast is going to be on section 15.6. I hope you're having a great day. This is a short one. Enjoy your evening.